So hey guys, welcome to today's video. In this video we are going to understand the graph concepts. We will not go through the theory in details because we don't require that. We all might be aware of the very basic terminology of the graphs. So we'll start with the graph concepts, which exactly what we need to know to solve the questions. Okay, so before we start, you should always remember that you should not be scared of the graphs. It's very easy. Once you start pursuing the questions, once you start doing it consistently, it is very easy. Okay, so with that, let's start first with the graph representations. So we need to understand it because while coding we need to represent graph, right, for solving the questions. So we need this concept. Okay, graph is represented as an adjacency matrix. So what does it mean? So you have this graph as an example. So it has four vertices, so which is 1, 2, 3 and 4. So we have four vertices. So edges, and these are its edges, like from 0 to 1 is one edge, 0 to 2 is one edge, 1 to 2 is one edge, and 1 to 3 is one edge. So if you see this graph, this is a directed graph because we have the arrows over here. Okay, since we have arrows, so it means it's a directed graph. Okay, so how do we draw the adjacency matrix? What do we do? For vertices equal to 4, we are going to draw a matrix ranging from 0 to v minus 1, which is like 0 to 3. So we will draw a 2D matrix like this: 0, 1, 2, 3, 0, 1, 2, 3. So this will be v cross v matrix. Okay, so let's number it: 0, 1, 2, 3, 0, 1, 2 and 3. Okay, now how do we represent this graph in this matrix? So if you see 0 to 1 is one direction, so we can go from 0 to 1. So how do we represent? So if you consider this as u and this as v, so in graph we represent something like this: u to v. So small u is kind of a source and v is our destination. So u to v. Okay, so here from 0 to 1, so from 0 to 1 we have a path, so we will make it as 1. You can add 1 or you can add a boolean true, that is also fine. Okay, but for simplicity we use the integer. It's an integer matrix of v cross v. Okay, now this is like one arrow we represented. Now from 0 to 2, this is one more. Okay, from 0 to 2 we will mark it as 1. Okay, now let's consider 1. From 1 to 2 there is one arrow. We'll not consider this arrow because it is one directional. It is only from 0 to 1 and not from 1 to 0. So from 1 to 2 we have one direction, so we will mark from 1 to 2 as 1. Now from 1 to 3, so 1 to 3 is also 1. Now from 2 there is no arrow going outward, and from 3 also we are not there is no arrow going outward. Okay, now rest of them will be 0. Okay, since there is no other nodes or no other edges, so we are going to mark it as 0. So this is for unidirectional, or like for the directed graph. So now let's understand how we are going to represent a undirected graph. Okay, so if I remove this edges with the arrows, and if I just add like this. Okay, so now what all changes we need to do? So it means like 1 to 0 we have an edge, and now from 1 to 0 also we have an edge. So what we are going to do, we are going to change in the matrix. So from 1 to 0 we have connection. From 0 to 1 also we are going to, from 0 to 1 we have a direction. Now from 1 to 0 also we are going to make a direction, so we will mark it as this also as 1. Okay, now from 0 to 2 we already have, 0 to 2 we have, and now from 2 to 0, so we are going to make this also as 1. Okay, now from 1 to 3 we already have it. Now from 3 to 1, from 3 to 1 we are going to mark this as 1. Okay, and we had one more over here, 1 to 2. So 1 to 2 we already have. From 2 to 1 also we are going to mark it as 1. Okay, so if you see it as a fact, so if you draw a line over here, so it will be a symmetric, it will be symmetric, like this and this will be equal, this and this will be equal. Okay, so this and this will be equal. Okay, so diagonally it will be equal. Okay, so this one, this one, this one, this one, okay, this one, so all will be diagonally symmetric. Okay, this is like one of the property for the adjacency matrix of the undirected graph. Undirected graph we call it UDG, and for directed graph we call it DG. So this is like one of the way, but the problem with this is like whether you have a connection or not. Because if you see over here, so we have all these zeros over here, right? 0 0 0, because there is, even though there is no relationship, still we are occupying those space. So the space will always be v cross v, this space. So our space complexity will always be v square. Okay, whether we use it or not, it will always be v square. So for not to waste that particular space, so there is one more representation which is called adjacency list, and this is the way what we are going to use to solve all our questions. Okay, so now what is adjacency list? We have the node as 0. From 0 we can go to 1 and 2, right? Now from 1 we can go to 2. From 2 we cannot go to anywhere, so we'll leave it as it is. And from 1 we can go 2 and 3 both. Okay, these two are there. Now from 3 we cannot go to anywhere. So for this purpose we are going to use only this much space. Okay, we are not going to save this particular thing, or we will not going to use these spaces, right? So what is the best way to use it? So we can use either a map. Why map? So in the map what we can do, we can just save 0 and we can add a list. So we can add a list, and in the list we can add 2 and 3. So the starting node will be your key, and the value will be your list of the nodes where it will reach. Okay, so now for 1 it will be 2 and 3, and for 2 it will be nothing, you can call it as null, and from 3 also we'll call it as null. Okay, usually we name this as ADJ, adjacency list. Okay, and we use this, either you can use the map, the unordered map or the hash map, or we can use array list array. Okay, so we are going to create an array of all the starting nodes like 0 1 2 3, which is like for this index 0 1 2 and 3. Okay, remove it. And for this list, and for the list it will point to an all the array list. So it should, for 3 it should be null, for 2 it should be null, and for 1 it will point to 2 and 3, and for 0 it will point to 1 and 2. So this is how we represent adjacency list in the directed graph. Okay, now for the undirected graph, it is in the same way. Okay, I'll just clean this up a bit. Okay, so now if I remove the arrow and if I'll make it undirected, so now if you see from 0 to 1, if there is a way, then 1 to 0 is also one of the way. Okay, now from 0 we can go to 1 and 2, which is fine. From 1 we can go to 2, 3 and 0 as well. Okay, just make it with this 0 also. Now from 2 also we can go to 0 and 1. Now from 3 we can go to 1. So it's a bidirectional thing. Okay, so we are going to represent the same thing, but in both the ways. Okay, this is what is called adjacency list. Okay, now since we understood how we are going to represent our graph, whether it is a matrix or the adjacency list, now the third concept we need to understand is how we are going to identify the graph questions. Like how do we know that this question is of graph and we are going to solve it? So there are some pointers. So one thing is like entity. So you will always be given some entities like a city, or a very famous question is course schedule. You will be given courses. So there will always be some entity and some relationships between those entities, and the hint will be something of that sort, that you are going towards from one place to another, like you are moving like from one entity to another. There will be some relationship with the edges. It will give you a hint that there is an edge between those two. Like even if you have a city, so suppose you have three cities, then you can be connected from one way or two way. Like you have friends in social media, you should be able to connect it. So there will always be a hint of a relationships. Okay, that is defined by the edges. And the third thing is like you can always have a direct questions, tell me that whether a graph is a bipartite or not, or you will get find a cycle in the graph or something of that sort. So these things you'll be able some of the questions will be very direct from your interviewer, and you should be able to solve those questions as well. Hope you understood the basic of the graph representations, and going forward we are going to understand some more concepts. We will keep the theory as minimal as possible, so that we will read a little bit of theory and we will solve the questions, so that we will build that understanding that this is the particular question and we are going to apply these type of concepts in these particular questions. This is how we will learn. Okay, hope you understood this. See you in the next. Thank you.